Alright, just a reminder, and I've written it down, that tan A plus B is tan A plus tan B, or 1 minus tan A tan B. So this is just an interesting way to use compound angles for this question, to solve this question. And you might not see it straight away, so I'll show you an alternative method as well. But when we look at this, you can almost see, or you might be able to see, that we can use compound angles here, because instead of 1 we know that tan pi on 4 is 1. So if we rewrite that as 1 as tan pi on 4 plus tan x, then if you think about it, looking at here, I want 1 minus, oh, I've already got 1 minus, awesome. And then tan A tan B, well, 1 times tan x is the same as tan pi on 4 times tan x. So you can see that this just comes from the compound angle of tan pi on 4 plus x. Alright, so if we want our pi on 4 plus x, we need to inverse tan, and the inverse tan of root 3, we know 60 degrees, or pi on 3, and if we're doing it between 0 and 2 pi, in this case, if I did add pi on 4 to here, I've got pi on 4, I've added pi on 4 plus x, and I've got 2 pi plus pi on 4. So if you think we're going around the unit circle here, from pi on 4, so from here all the way around to here this time, and we want tan is positive, so all stations to central. So we are looking in here, which we've got pi on 3, a third of a pi as opposed to a quarter of pi, so we're all good there. So we're up here. What else am I doing? Yep, so we're here, so that's fine, but we also want the one that's here, which would be pi plus pi on 3, so 3 pi on 3 plus pi on 3 is 4 pi on 3. Sorry, bad explanation. And then we're subtracting, so now we're in this domain, we're all good. Now subtracting pi on 4, so again, if you would like, we can put everything in 12s if you're not using a calculator. So to make this on 12 originally, this would be 4 pi on 12, and we're taking away, so on 12 this would be 3 pi on 12, and the other one on 12, so we're timesing by 4, so we've got 16 pi on 12 minus 3 pi on 12 is what we're doing. So we get pi on 12, and we get 13 pi on 12, I hope that's right, just in case, but of course you can use a calculator, but we're getting those two answers. So that's a fun way to use your compound angles. Now if you didn't see that straight away, that's okay, let's see what you could have done. So you may want to pause there and just try that out for yourself. I'm going to go back to the beginning. Alright, so say I didn't see that straight away, and instead, which is what we might do, we kind of look at this and go, oh, that's root 3 minus root 3 tan x. If I multiply it over there, that gives me a 1 plus, I'm going to do it over here, 1 plus root 3 lots of tan x's. If I put all the tan x's on this side and on the other side, I'll have root 3 minus 1. Alright, so that means tan x is root 3 minus 1 on root 3 plus 1, or 1 plus root 3, it doesn't matter which way we do it. Then you kind of go, oh, that's interesting, I could just put that in the calculator and do an inverse tan of that. But the other thing you do here is go, oh, I know all these, they're exact ratios, so let's see if we can figure them out in terms of tan. So this root 3 we know is our 60, so tan 60, so tan pi on 3. We know the 1 is tan pi on 4, and then we've got that 1 plus again, so we can have 1 times root 3, so 1 is tan pi on 4, and root 3 is tan pi on 3. So you may then see it here that you have tan x being this compound angle. So this time you've got the minus happening. You've got pi on 3 minus pi on 4. So our x in this case, which is pi on 12, right? Yeah. So pi on 3 minus pi on 4 is pi on 12. So our x is going to be pi on 12, but of course we've got to go around to the all stations 2 quadrant. So we've also got pi plus pi on 12, so that's 12 pi on 12 plus pi on 12, which is 13 pi on 12. So there's another way to look at it. I don't know if that's more difficult or easier, but there's a couple of fun ways to use your compound angles to solve that question.